It takes teamwork to assure that farm equipment will do a top job in the field. Each member of that team, dealer, service technician, and customer, is responsible for important duties, and each must do his job well. This program examines the role people play in machine performance and shows some of the ways you can maximize field performance. The first step comes in selecting the right tractor for the job. Here, the dealer plays a vital role as a consultant and advisor to the customer. Tractor requirements differ greatly among regions, crops, soil types, and individual farms. A tractor can be tailored to almost any operation, but this same flexibility can also result in a tractor that's all wrong. It's up to the dealer and customer to make the right choices. Selecting the right implement is equally important. It must fit both the tractor and the farming operation. With so many variables, it's hard to offer advice. The best type of implement will depend on the soil characteristics, farming operation, other equipment, and the special needs of the farmer. The farmer's own experience, his neighbors, and his John Deere dealer can all provide guidelines. The same voice of experience is needed to select the best size implement. The implement operator's manual will generally list minimum and maximum acceptable power levels, but this is only a guide and will not apply under all conditions. The greatest variable is soil type, and the differences are amazing. For instance, it may take 4 times as much power to pull a chisel plow in hard, dry soil as in sandy loam. The customer's own soil is the number one consideration in the selection of an implement. If the tractor is too large for the implement could be damaged, and the tractor would waste time and fuel. Even worse is to have an implement too large for the tractor. The implement will perform poorly, and the tractor powertrain could be overloaded, shortening its service life. In either case, draft response may not be satisfactory. Compared to the tractors of a generation ago, modern tractors are powerful and light. They are designed for high-speed farming. There are 2 ways to use a powerful tractor: pull a heavy load at a slow speed or a light load at a faster speed. Farmers are encouraged to use the lighter load and faster speed whenever possible. Doing so will save money several ways. For one, smaller implements naturally cost less. It's often possible to increase productivity by stepping up to a larger tractor and pulling the same implement at a faster speed. Please understand that we are not suggesting breakneck speeds. About 5 miles per hour, or 8 kilometers per hour, is ideal for many field operations. To pull a large implement at a slower speed, it is necessary to heavily ballast the tractor. This increases soil compaction, rolling resistance, and the chances of getting stuck. We'll have more on ballasting later. Using the larger implement and slower speed may also shorten powertrain life because the strain on gears, shafts, and bearings is proportional to the load being pulled. The engine works equally hard either way, but the powertrain works much harder when the larger implement is pulled at slower speeds. The tractor operator's manual includes this statement: avoid loads so heavy they require the lowest gears. To extend tire life and avoid excessive wear of drivetrain components, avoid continuous full load operation at ground speeds below 4.4 miles per hour or 7.1 kilometers per hour. Any load that can't be pulled at that speed is too heavy. Consistently pulling heavier loads will cause powertrain parts to wear faster. This graph compares overloading on the vertical scale to powertrain life on the horizontal scale, based on research by universities and manufacturers. Note that overloading a tractor by only 15% will cut the normal drivetrain life in half. This applies to any tractor, regardless of make. On certain implements, such as moldboard plows and subsoilers, the draft load increases significantly at higher speeds. Pulling them too fast will waste energy and reduce productivity. This graph compares drawbar load on the vertical scale to speed for a plow and a disc. The draft load for the plow increases faster than that for the disc, but both can be pulled at 5 miles per hour or 8 kilometers per hour with good results. Let's assume the right tractor and implement have been chosen for the job. Then you're on the right track, but there are still many details. Proper hitching, for instance. This often requires much more than just dropping a pin in a drawbar. The drawbar has adjustments. Length, height, and horizontal position may all be adjustable. A drawbar clevis assembly may or may not be needed. Each PTO category has a recommended distance back and down from the PTO shaft to the hitch point. The drawbar must be in the proper position to avoid damaging the PTO driveline. When connecting the driveline, it's important to always check for any potential interference and also make certain integral shields rotate freely on the shaft. Hydraulic hoses must be properly connected. Pulling the control lever back must extend the cylinder and raise the implement. Reversed hoses may be confusing and possibly dangerous. On a John Deere cylinder, the hose end with a groove goes to the notched side of the coupler. Unmarked hoses are easy to mark with tape, paint, or wire. 3-point hitch mounted implements offer maximum convenience and are being used by more and more farmers. A quick coupler makes the hitch even more convenient. To hold the implement securely, the implement hitch pins must be fully seated in the quick coupler hooks, and the latches must be properly engaged. Adjusting the center link levels the implement front to rear. This also determines how easily certain implements enter the ground, but the final adjustment must be made in the field. Adjusting the lift links levels the implement side to side. A flat floor or driveway is a good place to check. The lift links must not exceed the maximum length specified in the operator's manual. Vertical movement at the end of the implement, called lateral float, should be permitted for any implement with gauge wheels. This allows either side to rise slightly as the implement follows uneven ground contours. Depending on tractor model, a pin is either turned 90 degrees or moved to a different hole to permit lateral float. When using implements without gauge wheels, the pins should always be positioned to lock out lateral float. A certain amount of side sway is built into the hitch. This sway should be permitted for some implements and not for others. Each implement operator's manual contains specific instructions. Sway blocks control the side sway. Mounted in one position, they prevent sway. In a different position, they permit sway when the hitch is lowered, but not when it's raised. For stability in transport, sway should never be permitted when the hitch is raised. Since most tractor hitches are adjustable for 2 different categories or sizes, the sway blocks must also be set for the hitch category being used. On some tractors, the sway block is rotated 90 degrees, giving a thicker dimension for the wider category. On others, the draft link bumpers are turned end for end. If the hitch still has too much side sway, even with sway blocks properly positioned, shims can be installed to take up the slack. They fit behind the sway blocks or the draft link bumpers. On some implements, the hitch points can be moved relative to the frame. Each implement is different, and every implement operator's manual contains instructions for adjusting. We can't overemphasize the importance of carefully adjusting all implements. Without it, they will do a poor job and may pull much harder, wasting fuel and increasing wear. This plow is a good example. Without proper setup and adjustment, it would be hard to pull and hard to control. If polished surfaces were allowed to rust, it would not scour properly and would pull even harder. If worn parts were not replaced, the problem would gradually become worse. Proper care will make a world of difference, and the reduced load may save up to a quarter tank of fuel per day. Probably no other part of the tractor offers greater versatility than the hydraulic system. Many operators do not take full advantage of the many features of the hydraulic system. Even some of the simplest things are often overlooked, like the rock shaft depth stop. It's handy and helpful. The rock shaft height stop can prevent interference when the hitch is fully raised. It allows a semi-integral plow to be carried level in transport, preventing damage in the turns. The speed of drop should be adjusted to match each implement. A heavy implement drops faster, so the valve must be closed slightly to compensate for the weight. The same applies to remote hydraulic cylinders. Fully extending or retracting any cylinder should take at least 2 seconds. The draft sensing hitch, often called load and depth control, adds versatility, productivity, and convenience. Beyond just understanding how it works, the customer should experiment until he finds which setting works best for each implement and condition. The draft sensing hitch maintains a constant implement draft or pull. If draft starts to increase, the hitch automatically raises the rock shaft slightly to reduce the load and transfer weight to the tractor. If draft starts to decrease, it drops the implement deeper. This helps in several ways. First, by raising the implement slightly in the tough spots, it eliminates downshifting, saving time and bother. With no need to power up and ballast for the intermittent hard spots, fuel is saved and soil compaction reduced. A second big advantage is that it keeps depth more uniform in hilly ground. Instead of going deep in the low spots and shallow on hills, the implement maintains a fairly constant depth, resulting from the constant draft. Should the tractor tires sink into soft soil, the draft sensing hitch stops the implement from digging deeper. Many times, this can keep the tractor from getting stuck. The draft sensing hitch can also save fuel. Without it, the customer would have to use too large a tractor, ballast it too heavily, and run in too low a gear just to handle the tough spots. Only in the field can the proper degree of sensitivity be determined. It's usually best to start in maximum, then gradually reduce sensitivity if necessary. If an implement will not reach the desired depth, or if it constantly moves up and down, move the lever toward minimum. When you don't want the rock shaft to move, regardless of load, set the selector level in minimum. Always set the lever in this position before attaching or removing an implement, so the rock shaft will not move unexpectedly. When using an implement with gauge wheels, set the selector lever in minimum and push the rock shaft control lever all the way forward. The rock shaft will then float to follow the ground contour. Whatever the job, the fine-tuning can be done only in the field. It takes a few minutes to see what works best. As conditions change, a good operator makes minor adjustments. Maximum field performance comes only to the operator who's constantly alert.